Brand new lesson. This is how beyond numbers where we learn math the easy way. Now in this lesson we are looking at multiplying algebraic fractions. You get to realize that multiplication of algebraic fractions is quite simple than addition and subtraction, as we have considered in the previous lesson. Look at the two methods, then we look at the step-by-step process, and then we solve some examples. Get your notepad and your pens. Let's learn together. We'll first of all consider the two methods, and then you decide on which you would be comfortable in using. Now, the table you see on your screen summarizes the two methods. The first one says you simplify after multiplying. Then the second one, you would simplify before multiplying. So talking of these two methods, the first one, you'd have to simplify after multiplying. The second, you'd have to simplify before multiplying. Simplifying after multiplying simply means you multiply everything across first. That is numerator to numerator, then the denominator to denominator, and then you reduce the final fraction to its simplest form. For simplifying before multiplying, you would have to cancel out. So vertically or diagonally, and then you would go on to multiply. There are pros and cons for these two methods. For simplifying after multiplying, it is harder to miss a term, so you'd always get it right. But then you end up with very large numbers, which makes it difficult to simplify. When it comes to simplifying before multiplying, you keep the numbers very, very small and manageable. But then you might miss some of the numbers if you don't look at it keenly. For this lesson, we'll be looking at how to simplify before multiplying. So please pay attention and work along. Now, since we'll be looking at the simplification before multiplying, anytime we are given a question, these are the processes we need to make sure we follow. First of all, make sure you factorize everything. So if you're able to factorize everything, that is where you can cancel out if there are common terms. After canceling out and then there's no common term, now multiply across and then you check for your final solution. With this in mind, let's take some examples and solve. So let's start with this very simple question here, which says 3x squared over 4y then multiplied by 2y over 9x. So for this type of question, since we are using simplification before multiplication, the first thing you want to do is you factorize everything. And with this, there's nothing to factorize. So since there's nothing to factorize, we then cancel out the common factors. When it comes to canceling, you can either do it vertically or diagonally, just like how you work the normal fractions. Hence, we have 3 dividing itself once, and it divides 9 3 times. 2 also divides itself once, and then it divides 4 twice. So with the numbers, we are done. There is an x over here that can take out one of the x's over here, so that we have just one more x left. There is this y that can also take out this y. What do we have left? For this particular fraction, we have 1 over 2. Any other variable has been cancelled. We have x over y. That is the x from 1 times x. And then we have 1 times x, which is x over, there is 2 as the denominator here. Then times, for the numerator here, we have just 1 over, then 3. So after this simplification, we then go on with our multiplication. Numerator times numerator, denominator times denominator. So that we have x times 1 giving us what? X over 2 times 3, which also gives us a 6. You see how simple it is? Let's look at another example. And in this one, we would have to do some factorizations. Now, in this second example, as you can see, we have x squared minus 1 over 5x, then times 10x squared over x plus 1. So what do? You take note that there is a need for us to factorize. In talking of factorization, the numerator here is a difference of 2 squares. That is x squared minus 1, which can be written as x squared minus 1 squared. Applying the formula or the identity of difference of 2 squares, we have x minus 1 and then x plus 1. That is how we factorize difference of 2 squares. With that, we come and then do our necessary substitution here. So that instead of x squared minus 1, we are going to write the x minus 1, then x plus 1 over 5x, then times, is there anything to factorize here? We have 10x squared over x plus 1. So it is at this stage that we do our factorization. That's that. It is at this stage that we do our simplification by cancelling. So let me just write all this here again. So that for our cancellation, we said we can either do it vertically or diagonally. Looking at it in the vertical lens, there is nothing to cancel. But if we want to do it diagonally, we have x plus 1 here, and we have x plus 1 here. And since they are both factors, remember we said we can only cancel out if they are factors, not sums and differences. So this is 1 times x plus 1. So choosing to cancel first, there is nothing for us to cancel if we want to do it vertically, because this here has got no factor up here, and the same applies to what we have here. So let's choose to cancel diagonally. Starting with the numbers, we have 5 dividing itself once, then it divides 10 twice. I think that is all with the numbers. We have x plus 1, that divides x plus 1 here as well, give us 1. Then we have this x dividing this x squared to give us x. You take note. So you realize there's nothing for us to cancel anymore. Hence, we have our x minus 1 all over 1. And since it's over 1, we can choose not to write it. Then times 2 times x. 2 times x gives us a 2x over 1 as well, because there's nothing here. In that case, we have numerator times numerator, and then denominator also multiplying denominator. So that we have 2x, then times x minus 1 all over 1. And we know for fractions, if the denominator is 1, we choose not to write it. This becomes our final answer after the simplification of these fractions. Now, mind you, you can choose to still multiply through so that you'd expand it. So that your 2x multiplies x to give you 2x squared. And then 2x multiplies negative 1 to also give you a negative 2x. They are all correct. Now, there are some cases where either the numerator or the denominator might be quadratic expressions. And with that, you would have to factorize them before you can simplify. Let's take one last example that will have to do with that. So for this example we have here, you are required to simplify this whole thing. You realize that for this first one, the denominator is quadratic, and the numerator here is also quadratic. So how do we go about it? We have x plus 1 over x squared plus 3x, then plus 2, times x squared plus 5x plus 6 all over x plus 2. You don't just go straight forward and then say this x squared cancels out to this x squared. There is x here, it cancels x, the 3. No, we don't do that. You take your time and then make sure you factorize. Remember, we said we can cancel out factors and not sums and difference. Hence, we'll need to factorize the expression x squared plus 3x plus 2. That is this denominator here. Then we do the same to this as well. So let's first of all start with this. We have our a here being 1. So 1 times 2 gives us a 2. Then what are the factors of 2? Which when added gives us a 3? That is x squared plus. So for those two factors, which is 2 and then 1, we use it to expand the 3. So that we have x plus 2x2. So we now factorize in pairs. What does this first two terms have in common? They both have x. X times what gives us x squared, that is an x. And x times what gives us x, we have 1. For these two, they also have a positive 2 in common. And we have x plus 1, just as we have here. So since these two brackets are the same, we are going to write that out, which is x plus 1. Then we put the coefficient also in one bracket, which is x plus 2. For the second one, which was x squared plus 5x, and then plus 6, we still use our factorization to do that. To factorize, and we have the coefficient of x squared being 1. So 1 times 6 gives us a 6. The factor pairs of 6, which when added gives us 5, is what? 2 and then 3. Hence, we have x squared plus 2x plus 3x plus 6. What does these two have in common? They both have an x. So the x comes out and we have x plus 2. For this one too, they have 3 in common. And in our bracket, we have x plus 2. We have x plus 2 in one bracket. And in the other bracket, we have x plus 3. So we now come and then rewrite our fraction again. The first one becoming x plus 1 over, instead of x squared plus 3x plus 2, we are going to substitute that with this. So over x plus 1 and then x plus 2. Then times, instead of x squared plus 5x plus 6, we are going to write this, which is x plus 2 and then x plus 3 all over x plus 2. So it is at this stage that you check and see if there is anything to simplify. So talking of terms to simplify, we are going to try vertically first, if there are any terms that can even cancel out vertically. This numerator is x plus 1, and this is also x plus 1, so it can cancel out once, you see. Then when we come here, we also have x plus 2 and then x plus 2 over here, so they also cancel out. Is there any other thing we can cancel out? No. Hence, we can say for this particular fraction, which is the first one, the numerator was left with just 1 over 1 times x plus 2, which is x plus 2. Then times, for the numerator here, we have x plus 3 remaining over 1. And since there's nothing to cancel, take note, you don't cancel this x by this x. We cancel factors and not sums and differences. So 1 multiplies this whole numerator to give us x plus 3 all over. Then x plus 2 also multiplies 1 to give us an x plus 2. And this becomes the final answer to the simplification of this we have over here. I do hope this lesson was helpful. As usual, I'll leave you with some exercises so you try on your own to test your understanding. So here we have 5 questions you can try on your own. It's just an extension of all that we have done so far. If there's any issue of concern, you can always let me know at the comment section and I'll address that for you. Let's have beyond numbers where we learn maths the easy way. If this lesson was helpful, you can choose to subscribe if you so do wish, so that anytime I release a video, you'll be notified as well. See you in our next lesson where we look at division of algebraic fractions. Bye for now.